Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about Tuple Basics Part 2. That includes understanding about data types, indexing in tuple, be it positive and negative indexing, indexing with range function, extended slicing, and finally understanding about tuple repetition. Let's begin with understanding about data types in tuple. Tuples in Python offer the flexibility to store elements of different data types within a single container. This means you can have a mix of integers, strings, floats, and other data types all within one tuple. Let's look at the pseudocode representation of it. Step 1. Create a tuple with elements of different data types. Means start by defining a tuple with various types of data such as integers, strings, and floats. Step 2. Access and display the elements to confirm their data types. Means access each element of the tuple and display them to confirm their respective data types. This example here illustrates the creation of a tuple, my tuple, containing elements of different data types, including integers, strings, float, booleans, and even another tuple. When printed, my tuple displays all these elements within parentheses, showcasing the versatility of tuples to store heterogeneous data. Let's execute this and check. As discussed, here is the output. Now, let's move on to understanding about indexing. Tuple supports both positive and negative indexing to access elements. Positive indexing starts from 0, where the first element is indexed as 0, the second as 1, and so on and so forth. Conversely, negative indexing starts from -1, with the last element indexed as -1, the second last as -2, and so on. This dual indexing capability allows for flexible and convenient access to tuple elements, enabling retrieval from either end of the tuple based on the programmer's preference or requirements. Here is a syntax of both positive and negative indexing. This line retrieves the element at the specified positive index within the tuple mytuple. Conversely, this line allows you to access elements by counting positions from the end starting with index -1. Let's look at the pseudocode representation of it. Step 1. Initialize a list variable mytuple. Means begin by defining a tuple named mytuple. Step 2. Use positive indexing to access elements from the beginning. Means access elements from the start of the tuple using positive index values starting from 0. Step 3. Use negative indexing to access elements from the end. Means access elements from the end of the tuple using negative index values starting from -1. Step 4. Retrieve the element at the specified index. Means fetch the desired element at the specified index position either with positive or negative indexing. This example here demonstrates how both positive and negative indexing can be used to access elements from a tuple. In this example, we have a tuple named mytuple containing various elements including integer, string, float, a boolean, and another tuple. Using positive indexing, we retrieve the element at index 1, which is hello, and print it. Conversely, using negative indexing, we fetch the last element of the tuple, which is another tuple 1 to 3, and print it using print statement. Let's execute this and check. As discussed, the element at index 1 is hello and the element at last index is another tuple, that is 1 to 3. Now let's look at indexing with range. Indexing with range allows accessing a subset of elements from a tuple using a start and stop index. This is achieved through slicing. With slicing, you specify the range of indices you want to include in the subset, separating them with a colon. Here is a syntax of it. This line of code creates a subset named subset by slicing a tuple, mytuple, using the start and stop indices provided within square brackets. The start index denotes the beginning of the subset, while the stop index indicates where the subset ends. The resulting subset includes elements from mytuple within the specified range, allowing for extraction of a specific segment of elements from the original tuple. Let's look at the pseudocode representation of it. Step 1. Initialize a tuple variable mytuple, means begin by defining a tuple named mytuple. Step 2. Determine the start and stop indices, means decide on the start and stop indices to define the range of elements you want to extract. Step 3. Use slicing to access elements from start to stop -1, means use slicing with square brackets to access elements from start index up to but not including the stop index. Step 4. Assign the resulting subset to a variable subset means store the resulting subset in a new variable called subset. Here are four examples demonstrating indexing with range. In the first example, we have a tuple named mytuple containing letters A, B, C, and D. This line extracts elements starting from index 2 onwards until the end of the tuple. In the second example, we initialize a tuple named mytuple with numbers 0 to 5. This line indicates that we want elements from index 1 up to but not including index 4. In third example, we have a tuple named mytuple containing the letters A, B, C, and D. This line signifies we want elements from the beginning of the tuple up to but not including index 2. In the fourth example, we define a tuple, mytuple, with mixed data types. This line selects elements from the third last element up to but not including the last element. The output in all the four cases is printed using the print statement. Let's execute and check. As discussed, here are the outputs. Let's now look at extended slicing. Slicing in Python allows accessing a range of elements from a tuple. It can include a start index, stop index, and an optional step value. This line mentioned here creates a subset named sliced tuple by slicing a tuple, mytuple, using the start, stop, and step values provided within square brackets. As already mentioned, the start index determines the beginning of the slice. The stop index marks its end, which is exclusive, and the step value specifies the interval between elements to include. Let's look at the pseudocode representation of it. Step 1. Initialize a tuple variable mytuple means begin by defining a tuple named mytuple. Step 2. Determine the start, stop, and step values means decide on the start, stop, and step values to define the range of elements you want to extract. Step 3. Use slicing to access elements from start to stop -1 with the specified step means utilize slicing with square brackets to access elements from the start index up to but not including the stop index with the specified step between elements. Step 4. Assign the resulting sliced tuple to a variable sliced tuple means store the resulting sliced tuple in a new variable called sliced tuple. Here are four examples demonstrating extended slicing. In the first example, we start with a tuple, mytuple, containing numbers from 0 to 9. In this line, we aim to slice elements from index 1 up to but not including index 8 with a step of 2. Slicing yields 1, 3, 5, 7 as it includes elements at indices 1, 3, 5, and 7. We assign the sliced tuple to variable sliced tuple. In the second example, we have a tuple called mytuple with mixed data types. In this line, we slice from the beginning to the end with a step of 3. Slicing retrieves every third element from the tuple. The sliced tuple is assigned to the variable sliced tuple. In the third example, we define a tuple, mytuple, containing letters. In this line, we slice from index 4 down to index 1 with a step of 2 from backwards. Slicing results in E, C as the output as it includes elements at indices 4 and 2. The sliced tuple is assigned to the variable sliced tuple. In the fourth example, we start with a tuple, mytuple, containing numbers from 0 to 9. In this line, we slice from the last element to the sixth element backwards with a step of -2. Slicing extracts elements at indices -1, -3, and -5, resulting in 975 as output. The sliced tuple is assigned to the variable sliced tuple. We print the output of all these examples using the print statements. Let's execute this and check. As discussed, here are the outputs. Now let's look at the tuple repetition. Tuple repetition allows creating a new tuple by repeating the elements of an existing tuple a specified number of times. This operation is achieved using the multiplication operator, which multiplies the elements of the tuple by the specified number of repetitions. Here is a syntax of it. This line creates a new tuple named repeated tuple by repeating the elements of the existing tuple, mytuple, n times. Here, n represents the specified number of repetitions. Let's look at the pseudocode representation of it. Step 1. Initialize a tuple variable mytuple means start by defining a tuple named mytuple. Step 2. Determine the number of repetitions n means decide on the number of repetitions n you want for the elements of the tuple. Step 3. Use the multiplication operator to repeat the tuple n times. Means use the multiplication operator to repeat the elements of the tuple n times. Step 4. Assign the resulting tuple to a variable repeated tuple. Means store the resulting tuple in a variable called repeated tuple. Finally, here is an example demonstrating the application of tuple repetition to create a tuple with repeated elements. In this example, the tuple named myTuple contains a mix of data types. By using the multiplication operator, the elements of myTuple are repeated 5 times, generating a new tuple named repeated tuple. When printed, repeated tuple displays the elements of myTuple repeated 5 times. Let's execute this and check. As discussed, here is the output. This is all about today's lecture. See you in the next lecture. Thank you.